Hi, I'm Mr. Hayes, Hayes' World of Math. I'm here to help you do better on the AP's test, and hopefully, if your teacher has a wall of 5 like I do up there, get you up there. But if nothing else, get you credit for it. We're talking through CED 7. We're talking about means and inferences and confidence intervals. And before we do this, down below I have a link to a free 3-week review course. You can use anything on it. All the worksheets I have up there are downloadable. You can use those. There's links to videos. There's answer keys. There's all of that stuff that you need. So please make sure you do that. And while you're down there, like, comment, subscribe. So let's jump into this one. This question is from 2022. It's question number 5, which tends to be one that kind of mixes a couple of both. So this one is from 2022, question 5. They're talking about flavonoids that can help lower blood pressure, and different foods have them. And so they discovered that dark chocolate has them, white chocolate doesn't. So they have 25 participants, 13 in the dark chocolate group, 12 in the other one. They're eating some chocolate every day, loving their life. And anyway, so they check their blood pressure before they start doing all this and then after it. And because of that, when we're setting this up, and depending upon how they ask you, you may not need to write all this down, but it's still good to have it in the back of your head. I would make a note saying, okay, this is the mean difference before minus after. One person, you have one person taking 2 different measurements and then seeing how it's going bigger. They're finding all the differences between each, for each person, and they're averaging them out is the setup here. Now in this case here, we are going to, so they have all of the blood pressure out here. It looks nothing super skewed. Yeah, maybe a couple of outliers, but they're not even going to ask us to get there. So don't get too far ahead of yourself. Determine and compare the medians of the reduction of blood pressure. Question 5 tends to take 2 different topics and put them together, 2 topics that you know. In this case, they're going to do some stuff with medians and some of the display stuff, and then they're going to merge it with, do you know how to do inference? So in this case here, we need for dark chocolate, there's 13 of them, so we need the 7th piece of data, which would be this one. So that's going to be 7 for, and then white chocolate had 12, right? Yes. The white chocolate had 12, so we need to estimate between the 6th and the 7th, 2, 4, 6, so that means the median's right here, and so the median here is going to be 0. So the medians, the difference of the means of the reduction of blood pressure groups is going to be this. Median of the dark chocolate was 7. The median of the white chocolate was 0. So we have a difference. The median in the difference is 7. Technically 7, what are we doing? We're doing millimeters of mercury. Context. So the way that I would go through and say this, because obviously just showing it isn't enough, I would say something like this. The median reduction of blood pressure for those participants who ate dark chocolate is 7 points greater than those who ate white chocolate. Okay. Now the researchers found the mean reduction in the blood pressure for part B on those who consumed dark chocolate is 6.08. White chocolate was 0.42. One researcher indicated because the difference of the sample is 5.66, that gives us the convincing statistical evidence of what's going on. Why might the researcher's conclusion, based on only the difference of the sample, might not necessarily be true? Now, before I get into what I wrote here, since we're talking t-score here, okay, so we're going to look at the difference in means, right? So we're going to have x, the mean of the difference of the white chocolate, minus the mean of the difference of, that's dark chocolate minus white. So dark chocolate minus white chocolate minus 0. Now again, this is technically mean of dark chocolate, mean of white chocolate, because that's going to be our parameter, right? And then over on the bottom, remember, you need to have a standard deviation to go through and do this. And this is the part which the researcher doesn't do. This 5.66 is just the numerator. They haven't divided it through by any sort of variation. And so we do need the standard error, of dark chocolate squared divided by 13, plus the standard error of white chocolate squared divided by 12. And that's the point where this researcher fell through, which is also part of the reason why knowing statistics is important. So I would say something along the lines of this. The results could be purely by chance because for a result to be convincing, the variation needs to be small enough to cause the test statistic to be large enough to matter, which is probably more than I need to say, but it kind of works. So since we don't know the standard errors, we can't know if there's convincing evidence since we can't calculate it out of the test statistic. This last part is probably the biggest part, because in order for things to be convincing evidence, you need a test statistic so you can figure out the probability for it. We can't calculate it out because we don't have this part right down here. Okay. So notice now we're starting to get in. We went from some of the stuff from early in stats. Now we're kind of closing it out with some of the other ones. Now back over here, the simulation was conducted. So again, now we're going back to simulations, back CED 5, to investigate whether there's a greater reduction of blood pressure for those who consume too much chocolate than who don't. So they do 120 trials of just assuming that this would just be randomly selected, and this could be the difference between, random. I'm assuming what they'll do is that there's no difference. They randomly generated 2 different blood pressures. They did the subtraction. They went from here. Or they took the numbers that they had before, whatever. It doesn't matter. Why am I even talking about it? Use the results for the simulation to determine whether the 25 participants provide statistical evidence at the 5% level. Now, what do I need to know about that? Well, our number was 5.86. I actually have it marked up here. So this is going back to what you may have done, hopefully, in your class. In this simulation, 125 pieces of data, we only have 120 pieces of data. We only have 3 that went our level of difference of 5.66 or higher, which then would calculate out to be, come on, hello, guess we didn't do that, which would calculate out to be 0.025%. Well, that's nice. So and then now we're just going to go ahead and justify it and conclude what we have. This is going to sound really, really familiar for those of you guys playing along at home. If the mean difference is equal to 0, and we have to say that because we really don't have a null hypothesis in here. So you have to kind of spell that out here, that the dark minus white chocolate. Mean difference, I probably should say, of blood in reduction of blood pressure. We're kind of going through these a little bit fast in my class. My apologies. Dark minus white, there is a 0.025 probability of getting a mean difference of 5.66, or a mean difference greater than 5.66, we could even say equal to, purely by chance, because 0.025 is less than 0.5. Not sure why it's so clock. You guys really deserve better than that, I'm sorry. We have convincing, since we reject the null hypothesis, and we have convincing evidence that dark chocolate does reduce blood pressure more than white chocolate. So I hope that helps. Obviously, a couple of things. I'll put the playlist for these over here and a couple of other ones that we're doing, and we'll go from there. Catch you in a bit. Bye.